A premium truck tire, the kind going on the front axle of a loaded 18-wheeler, costs $400 to $600. New every time across 18 positions. But the operators actually running these fleets are not buying new tires every cycle. They are retreading. Same casing, new tread, and the bill drops to somewhere between $100 and $200. This is how that works, why it is safer than most people assume, and what separates a retread that runs 100,000 miles from one that ends up in pieces on the shoulder of Interstate 80. Let's start with the number that everyone in this industry already knows, but rarely says out loud. A premium steer tire from Michelin or Bridgestone, the kind that goes on the front axle of a loaded Class 8, runs $400 to $600. Continental and Goodyear commercial tires occupy similar price points. Drive axle tires and trailer tires, you are looking at $300 and up per unit. Multiply that across 18 positions. Factor in average tread life of around 100,000 miles under typical load and road conditions. And you start to see why tire costs routinely rank as the second or third largest operating expense for a trucking company, behind fuel and sometimes labor. The casing, though, the structural core of the tire, the steel belts, the bead and the sidewall, does not wear out with the tread. Under normal operating conditions, a quality casing has the structural integrity for 2, sometimes 3 retreads before it is retired. The tread is the consumable. The casing is the asset. Treating a worn drive tire like it is worthless because the tread is gone is the equivalent of scrapping an engine block because it needs new piston rings. This is why serious fleet operations do not just buy tires, they manage casings. A casing that is properly specified for the application, run at the correct inflation pressure, and pulled before the tread wears into the steel is a reusable asset with a multi-cycle service life. Fleets that track casing history, which retreader handled it, how many lives it has run, and what repairs were made, operate with a materially different cost structure than fleets that treat every worn tire as a line item disposal. The difference compounds quickly at scale when measuring cost per mile metrics. A 300 truck fleet cycling drive and trailer positions has thousands of casings moving through the system at any given time. Managing those casings as inventory rather than waste is its own operational discipline, and the fleets that do it well show it clearly in their per-mile tire costs. Retreading recognized this distinction in the 1940s. The United States government formalized it during World War II when rubber rationing made tire retreading a federal mandate. It was not a cost-saving measure, it was a national security measure. The military could not put new tires on every vehicle in every theater of operation. So the infrastructure for inspecting, buffing, and retreading casings was built out at scale, and when the war ended, the commercial trucking industry kept using it because the economics had not changed. They still have not. A quality retread on a drive or trailer position today runs $100 to $200 on a casing that cost you $400 2 years ago and has already logged its first life. You are extending that asset for less than half of replacement cost. A fleet running 300 trucks doing retreads on drive and trailer positions saves millions of dollars annually that stay in the operation instead of going to a tire manufacturer. The American Trucking Association has put the industry-wide savings figure in the billions. That number is not an exaggeration. Now, the question that always comes up, especially from anyone outside commercial trucking who has ever seen a retread carcass on the highway, is the safety question. It deserves a real answer, not a defensive one. The Federal Aviation Administration, the FAA, requires retreaded tires on commercial aircraft. American Airlines, Delta, United, and every major carrier operating out of every major airport in the country are landing on retreaded rubber. The FAA does not make that call because it is cheap. It makes that call because a retread produced inside a certified process is structurally equivalent to a new tire for its intended application. If that standard holds at 250 miles per hour on a 150-ton aircraft, it holds on Interstate 40 at 65 miles per hour. The highway debris question is real, and the industry has never pretended otherwise. But the data consistently points to a single cause, and that cause is almost never the retreading process itself. The Tire Retread and Repair Information Bureau, which has been tracking this for decades, identifies the primary failure modes as underinflation, overloading, and poor initial inspection at the retreading facility. The National Highway Traffic Safety Administration Commercial Medium Tire Debris Study confirms these findings. Bridgestone's own internal data from Bandig operations shows that more than half of all retread failures trace back to one thing: inadequate inspection of the casing before the retread process began. A casing that had internal damage, prior repairs that were not caught, or structural separation that was never identified got pushed through anyway. That is a quality control failure. It is not a retreading failure. This distinction matters enormously if you are making tire purchasing decisions for a fleet, because it means the quality spread between retreaders is not small. It is the entire ball game. Here is what a serious retreading operation actually looks like. A worn casing comes into the facility and gets a work order and a barcode. It is tracked from that point forward. Then it goes through an initial inspection, and this is not a quick walk around. The bandage process, which Bridgestone now runs as part of its commercial tire division, includes 7 discrete steps. First is visual inspection of the sidewall, the bead area, the inner liner, both sides, and the crown. The inspector uses their hands as much as their eyes, feeling for embedded objects like rocks, nails, and screws, anything a camera would miss. Any foreign object found is marked for removal. After visual inspection comes electrical inspection. A technician runs an electric impulse over the casing surface, and the current finds punctures and subsurface injuries that are invisible to the naked eye. A spark pinpoints the defect, and it is marked. This electrical check finds problems a simple look cannot. Then comes shearography. If you are not familiar with this technology, it is a laser-based scanning system that applies vacuum pressure to the casing while cameras capture surface deformation, any internal separation, delaminated plies, separated steel cords, or structural void shows up in the imaging. The entire casing is scanned bead to bead. A tire that passes visual and electrical inspection but fails shearography does not get retreaded. It is pulled and destroyed. The casings that clear all 3 stages move to the buffing machine, which removes the remaining tread rubber down to a consistent, clean surface profile. The buffer operates at a predetermined crown width, radius, and symmetrical profile. This is not just grinding off old rubber, it is precision preparation of the bonding surface. The uniformity of the buff directly affects how evenly the new tread seats and how well it performs under load. Then comes skiving. Technicians remove any damaged steel cord material, any corrosion, and any rock drill damage that could create a stress riser or a weak point in the bond zone. A chemical is applied to prevent oxidation and give the surface the tack the uncured rubber needs to adhere properly. After that, cushion gum, an uncured rubber compound, gets applied across the buffed surface. This is the adhesive and the bonding layer, and its thickness and consistency are critical. A pre-cured tread strip is then wrapped around the casing, measured and cut to exact circumference, spliced at the ends, and stitched down to eliminate any trapped air between the tread and the gum layer. This pre-cure retreading method, which applies a factory-cured tread to the prepared casing, differs from the mold cure process where uncured rubber is molded and vulcanized directly on the casing. Most commercial operations use pre-cure for its consistency and speed. The assembled tire is then sealed inside a flexible rubber envelope that conforms tightly to the tread contour and vacuum tested to confirm there are no leaks before it goes anywhere near a curing chamber. That vacuum seal ensures uniform pressure across every surface during cure. Then the tire goes into the chamber with controlled heat at 250 degrees Fahrenheit and specific pressure for 2 to 3 hours. The cushion gum vulcanizes. The tread bonds permanently to the casing at the molecular level. What comes out is a finished unit that goes through final inspection, gets logged into the facility's quality system with its full service history attached, and ships with the required DOT code certification that tracks the retreader and production date. That's a rigorous process. It's also only as good as the facility running it. This is the part that matters most for anyone sourcing retreads. Certified retreaders, facilities operating under Bandage's quality program, Michelin's Remix certification, or equivalent standards run every step of that process with calibrated equipment, documented reject rates, and traceable service records on every casing that moves through the plant. When a tire fails in the field, a certified facility can pull the record and tell you exactly what the casing looked like at intake, what repairs were made, and who signed off at each inspection stage. That accountability trail exists because the certification requires it. A facility without certification may be doing something that looks similar from the outside. It is not the same process. A casing that should have been rejected at chirography but was not looks identical to a properly inspected casing until it fails at speed. There is no visual difference between a quality retread and a compromised one sitting on your dock. You cannot inspect your way out of that problem after the fact. This is why sourcing from certified operations is not a preference. It is the only risk management position that makes sense. The small price differential between a certified and uncertified retread disappears entirely the first time you have an incident, a cargo claim, or a CSA violation tied to a tire failure. Fleet managers who have been in the industry long enough have usually learned this the hard way once. The ones who have not yet tend to find out during a roadside inspection on a rainy Tuesday in Ohio. There's also a resource dimension to retreading that tends to fly under the radar in conversations about fleet costs, but it matters for anyone thinking about where the industry is heading. Manufacturing a new commercial truck tire consumes approximately 22 gallons of oil equivalent in raw materials, the petroleum derivatives, the synthetic rubber compounds, and the steel cord coatings. Retreading the same casing consumes roughly 7 gallons. The casing itself, which represents 60 to 70% of the material value of the original tire, stays in service instead of going to a shredder or a chrome rubber processor. With 40 to 50 million retreads processed annually in the United States alone, that is a significant materials equation. It is not the primary reason fleets retread. The primary reason is always the cost math, but this is a real number, and it is increasingly relevant as sustainability reporting becomes part of how large shippers and carriers are evaluated by their customers and investors. The core logic of retreading has not changed since the 1940s. The tread wears, the casing survives, replacing only what actually wore out and doing it inside a process that verifies the structural integrity of what you are keeping is not a compromise. It is precision asset management. The fleet operators who figured this out early built cost structures that their competitors could not match. Those who still treat every worn tire as a disposal problem rather than a retreading candidate are leaving real money on the table every cycle, every year. The retread sitting on your drive axle right now, if it came from a certified facility and went onto a properly maintained casing, is not a second-class tire. It is the same tire making its second run. And if you think retreading is the only way the tire industry squeezes value out of rubber that most people write off as waste, wait until you see what Korea is doing with 400,000 tons of dead tires every single year. That story is next.